Welcome back in the lecture series of DSTL, Discrete Structure Theory of Logic. I am Francis Saxena, Department of Information Technology, ABES Engineering College. And today's topic of discussion is Introduction to Relation. So we will see what is the meaning of relation, and what are the different kind of relations. What are the different kind of relations we have? So we will see what is the definition of relation. So suppose we have set A, which contains say some elements, say 1 comma 2 comma 3 up to say n element, say cardinal number of A is n. Now we are trying to define Cartesian product over this side, so that Cartesian product will be written as A cross A, and this Cartesian product say contains ordered pair A comma B such that this A comma B belongs to set A. So this is the basic definition of Cartesian product. So every possible ordered pair forming from A cross A will be the part of this Cartesian product. So suppose relation, say Cartesian product on set A, which contains 1 comma 2 comma 3 elements. So that ordered pair can be some of the ordered pair I will name, like 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, so on up to 1 comma n, like 2 comma 1, 2 comma 3 up to 2n. So it will have say n cross n number of elements. So if I say what will be the cardinal number of this Cartesian product, that will become n into n, which is equal to n square. So any relation R is just a subset of this Cartesian product. So if I try to write a relation R on set A, so that will be the subset of Cartesian product and can be written as ordered pair A comma B, such that this A comma B should belongs to set A and A should be related to B. This is compulsion. Any ordered pair in which A is related to B with respect to any relation given, then only A comma B will be the part of relation. If A is not related to B, that will not be the part of relation. So the very famous question is, how many different relation can be produced if we have a set which contains a number of elements? So how many different relations we can write? So the answer of this question is very simple. So I will write the question first, different relation. Now the question is how many? So the answer is pretty much easier. Suppose we have say n square ordered pair in Cartesian product A cross A, and relation is just a subset of this Cartesian product. So that means any ordered pair which can be a part of relation or cannot be a part of relation. So there are n square ordered pair which can be a part of relation or which cannot be a part of relation. Or a simple, I can say, in n square ordered pair, I will choose 0 ordered pair, or in n square ordered pair, I will choose any 1 ordered pair. In n square ordered pair, I will choose any 2 ordered pair, and so on. In n square ordered pair, I will choose n square ordered pair. So this is one of the fundamental way to write a different kind of relation. Or this can be visualized this way also. We have only two possibilities to have any ordered pair in a relation or not. So either A comma B will be the part of relation or will not be the part of relation. If A comma B is the part of relation, the value will become 1. If A comma B is not part of relation, then value will become 0. So किसी भी ऑर्डर्ड पेयर की कोरिलेशन में होने के केवल दो ही पॉसिबल तरीके हैं, या तो वो होगा या नहीं होगा, और हमारे पास टोटल n स्क्वायर ऑर्डर्ड पेयर है. सो टोटल नंबर ऑफ तरीके, टोटल नंबर ऑफ डिफरेंट रिलेशन that can be formed, that will become 2 की power n square. So this is the basic definition of relation, and I have also told you what are the different kind of relations we have. Now we will discuss what are the different type of relations we have. Type of relation. So very first relation is reflexive relation. Say, if I try to define this relation, so we have set A on which a relation R is defined. This R is said to be reflexive only if for every A which belongs to capital A comma A should be the part of relation. So this is a basic definition of reflexive relation. We will try to learn this reflexive relation with certain example. So suppose I have a set 1, 2, 3, and relation R is defined on this set. So obviously we have to calculate a Cartesian product, say A cross A, that contains ordered pair like 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and 3, 1, 3, 2, 3, 3. So total 9 ordered pair which A cross A contains. Now, relation will be the part of, or say relation will be the subset of that Cartesian product. If I take some example, say R1, which contains nothing. So obviously, A cannot be a non-empty set. So if we try to calculate Cartesian product, so in this case, A should be non-empty set, but relation can be empty because relation is a subset of a Cartesian product. So it can also have nothing. So if I say relation number 2, which is equal to A cross A, if I try to write a relation which contains say 1, 1, 1, 2, two ordered pair. If I write another relation, say which contains 1, 1, 2, 2, 3, 3 kind of ordered pair. If I have a relation say R5, which contains say 1, 1, 2, 2, and if I have R6, which contains say 1, 1, 2, 2, 3, 3, 1, 2 kind of order. So now the question is which relation is reflexive or not? So the definition is for every A. Now in my case, A is either 1 or 2 or 3. So for every A which belongs to capital A, so capital A contains only 3 elements, which I told you earlier, that A comma A should be the part of relation. So this is compulsion. So every A comma A should be the part of relation. So first relation is say R1, which contains nothing. तो इस रिलेशन में ना तो 1 1 है, ना ही 2 2 है, ना ही 3 3 है. So this equation is not satisfied. So this relation is not reflexive relation. Now if I talk about A cross A contains every possible ordered pair. So definitely A cross A contains 1, 1, 2, 2, 3, 3, 3, and many more different ordered pairs also, but it contains 1, 1, 2, 2, 3, 3. So this is what the condition says. So A cross A is a say reflexive relation. Now if I talk about R3 contains 1, 1, so that means one ordered pair is okay. Now R3 does not contains 2, 2 and 3, 3. और यहाँ पर जो इक्वेशन है वो कह रही है कि फॉर एवरी ए विच बिलोंग्स टू ए कॉमा ए विल बी द पार्ट ऑफ रिलेशन. सो 1, 1 तो है लेकिन 2, 2 एंड 3, 3 नहीं है. सो अगेन दिस रिलेशन इज नॉट ए reflexive relation. Now if I talk about R4, 1, 1 भी है, 2, 2 भी है, 3, 3 है. So definitely this is a reflexive relation. R5, 1, 1 है, 2, 2 है, but 3, 3 नहीं है. So this is not a reflexive relation. 1, 1 है, 2, 2 है, 3, 3 है, 1, 2 कुछ हो या ना हो लेकिन ये होना चाहिए. If diagonal elements are present, then relation is reflexive. Diagonal means suppose if I try to calculate A cross A on this set, so this will become 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. So this is said to be diagonal element. So in reflexive, this diagonal element should be there. बाकी चाहे कुछ हो या ना हो, but diagonal element होने ही चाहिए. Now the three questions comes from this reflexive relation. Very first question is what will be the very say smallest relation in case of reflexivity, and what will be the cardinal number of that relation. So suppose we have a set A which contains an element. So the very smallest say reflexive relation will become those relation which contains only diagonal element. So the cardinal number of that relation will be, in my case, the cardinal number is 3, but if A contains n number of element, then smallest one will become, smallest relation will have, say, n number of ordered pair. So smallest in my case, that will become 1, 1, 2, 2, and 3, 3. So this will be the smallest. And what will be the biggest? Biggest means A cross A, which contains every possible of ordered pair. So 1, 1 भी होगा, और बाकी जितने भी ऑर्डर्ड पेयर पॉसिबल हो रहे हैं, सारे के सारे ऑर्डर पेयर को हम कंप्राइज करेंगे, तो रिलेशन आपकी डेफिनेटली रिफ्लेक्सिव हो जाएगी. दैट मींस ए क्रॉस ए. now the very important question is, how many reflexive relations can be formed? So to answer this question, we will move to the next slide. So suppose we have a set A which contains a number of elements, and a Cartesian product over this set A is calculated like this one. So which contains ordered pairs like 1, 1, 1, 2, 1, n, 2, 1, 2, 2, 2, n. Likewise 3, 1, 4, 1, n, 1, n, 2, n, n also. So if I talk about what will be the, say, cardinal number of this A cross A, that will become n into n, which is equal to n square. Now the question is, how many reflexive relations can be possible, or say different reflexive relations can be possible. तो इस कॉन्सेप्ट से एक बात तो बेसिक है कि अगर रिलेशन को रिफ्लेक्सिव बनाना है तो उसमें डायगोनल एलिमेंट को होना ही है. सो दैट मीन्स 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Any possible diagonal element should be the part of relation. So इस डायगोनल एलिमेंट को चूज करने का केवल एक ही तरीका, ये तो रिलेशन का पार्ट होना चाहिए. बाकी ऑफ डायगोनल में कुछ हो भी सकता है, नहीं भी हो सकता है. देयर आर लॉट ऑफ पॉसिबिलिटी कैन बी पॉसिबल. So if I try to divide this A cross A in two parts. So first part we have A cross A whose cardinal number is n square, and this n square is divided into two parts. First part is diagonal element, and second part is off diagonal element. So if I talk about say how many diagonal element we have, so we have n square, say n total number of diagonal element. And if I try to calculate say off diagonal element, that will become n square minus n. तो टोटल n स्क्वायर थे, इसमें से n माइनस कर दिए, तो अपर ट्राइंगल और लोअर ट्राइंगल दोनों को मिलाकर ये टोटल नंबर ऑफ एलिमेंट बन गया. Now, if I try to calculate how many reflexive relations can be made with the help of this diagonal and off diagonal element, तो अगर हम diagonal element की बात करें तो इसे चूज करने का केवल एक ही तरीका होगा, क्योंकि किसी भी रिफ्लेक्सिव रिलेशन में ये तो होना ही, ये पूरा का पूरा जो आपको सेडेड मार्क्स दिख रहा है, सेडेड पार्ट दिख रहा है, ये तो रिलेशन का पार्ट होगा ही, और इसे चूज करने का एक ही तरीका होगा. बिकॉज चाहे आप ऑर्डर पर 1, 1, 2, 2 लिखें या फिर 2, 2, 1, 1 लिखें, रियली नॉट मैटर, बिकॉज रिलेशन इज जस्ट ए कलेक्शन ऑफ ऑर्डर्ड पेयर विच कैन बी अनऑर्डर्ड. ऑर्डरिंग मैटर नहीं करती है कि 1, 1 पहले आएगा या 2, 2 पहले आएगा, बस ये मैटर करता है कि ये पूरा का पूरा डायगोनल एलिमेंट आना चाहिए. नाउ इफ आई टॉक अबाउट ऑफ डायगोनल एलिमेंट, नाउ देयर आर n स्क्वायर माइनस n ऑफ डायगोनल एलिमेंट, जिसमें से कुछ लोअर ट्रायंगल एलिमेंट होंगे और कुछ अपर ट्रायंगल एलिमेंट. तो इसमें से कोई भी ट्रायंगल एलिमेंट, कोई भी एलिमेंट सपोज 2, 1 आ भी सकता है और नहीं भी आ सकता है. तो कोई भी ऑर्डर्ड पेयर हम पिक करेंगे, उसकी दो पॉसिबिलिटीज होंगी, या 2, 1 रिलेशन का पार्ट होगा या नहीं होगा. दोनों केस में रिलेशन रिफ्लेक्सिव होगा. n, 1 या तो रिलेशन का पार्ट होगा या नहीं होगा. n, 2 या तो रिलेशन का पार्ट होगा या नहीं होगा. सिमिलरली एवरी पॉसिबल ऑर्डर्ड पेयर, हर ऑर्डर्ड के पेयर के पास दो ही पॉसिबिलिटी एसोसिएटेड है. आइदर उसकी वैल्यू 0 होगी, दैट मींस वो एब्सेंट होगा, या उसकी वैल्यू 1 होगी, प्रेजेंट होगा. या तो इसकी वैल्यू 0 होगी या इसकी वैल्यू 1 होगी, या तो इसकी वैल्यू 0 होगी या इसकी वैल्यू 1 होगी, या तो इसकी वैल्यू 0 होगी या इसकी वैल्यू 1 होगी. 0 मीन्स एब्सेंट एंड 1 मीन्स प्रेजेंट. तो टोटल हमारे पास n स्क्वायर माइनस n है, हर की पॉसिबिलिटी 2 है. सो जो टोटल नंबर ऑफ तरीके बनेंगे वो बनेंगे 2 की पावर n स्क्वायर माइनस. दैट मीन्स 2 की पावर n, n minus 1, that will be total number of reflexive relations then can be possible with the help of a set A which contains an element. Now, we can visualize this relation another way, like डायगोनल एलिमेंट को चूज करने का एक ही तरीका था, सो 1. नाउ अगर हम ऑफ डायगोनल एलिमेंट की बात करें तो हमारे पास जो n स्क्वायर माइनस n एलिमेंट थे, अगर इसमें से हम कोई भी एलिमेंट पिक नहीं करेंगे तब भी रिलेशन आपकी रिफ्लेक्सिव होगी. प्लस अगर उसमें से हम डायगोनल एलिमेंट पिक कर लेते हैं और साथ साथ ऑफ डायगोनल में से कोई भी एक एलिमेंट पिक कर लेते हैं तब भी आपकी रिलेशन रिफ्लेक्सिव रहने वाली. सिमिलरली डायगोनल में से एक और ऑफ डायगोनल में से अगर हम दो एलिमेंट पिक कर लेते हैं देन ओनली माय रिलेशन इज रिफ्लेक्सिव. Similarly, if I pick a diagonal element with the help of only one type and n square minus c n square minus n. So this will be another way to write total number of reflexive relations. So if we try to discuss another say type of relation that will be irreflexive relation, so we will continue irreflexive relation in the next say lecture. So